All right, we are on to day 2 of mirrors. We are going to do a quick review of what we learned yesterday with concave, and then we are going to move into the other type of curved mirror, which is convex. All right, so review problem. We are going to put our object looking into the mirror. Always goes on the left side in the shape of an arrow. It is going to be 3 centimeters in front of the mirror. It is going to have a starting height of 1.2. And then we're going to measure out a focal point of 1.3. All right, so I take my protractor. I measure out 3 centimeters. So I place it here. I measure 3 centimeters in front of the mirror on your paper. I'm going to use my protractor just on my iPad screen. I am going to measure it 3 centimeters in front of the mirror, and I'm going to notch it like that. Then, at that location, I need to make an arrow that has a height of 1.2. Okay, so once again, I'm going to put it right there, and I am going to have a height of 1.2. Please measure it out. And then the last thing that I need before I draw my lines, I need a focal point to run the lines through. That is going to be in front of the mirror to the left, 1.3 centimeters. So I'm going to go 1.3 centimeters in front of the mirror, notch it a little bit, and then I'm going to label that F. Okay, so for my 2 lines, first line, straight, use your straight edge. Straight line until you hit the surface of the mirror. It then bounces off through the focal point, like that. Second light ray, I always go in blue. This light ray is going to go through the focal point on the way to the mirror. And then it always bounces straight back, parallel with this dashed line right here. Please do better than me. Use the straight edge as you're doing it. It's just hard to line it all up on my iPad. They intersect at one point. That point is right here. So we're looking for the bounce back lines where they intersect. It's going to be right there for it. Ignore the focal point. This is where we're looking at. And to that, I draw an arrow to it, so I have something to measure. I'm going to measure 2 things. Q is the distance from this intersection point along the principal axis back to the mirror. I'm going to measure that purple line. That is going to be Q. Okay, I'm just going to place my protractor right on it. I get it to be about 2.2. Mathematically, perfect is about 2.3. So I take a range of about 1.8 to 2.8. All right, so as long as your distance to your intersection point back to the mirror fell in that range right there, you did a good job for the first problem here. Then the other thing that I'm going to measure is the height of the object. Height of the image, the HI. It will be negative because it's pointing below this dashed line. It's showing that it's an upside down image. And then once again, you just place your protractor there, you measure it. I got mine to be about 0.8. The mathematical answer is about 0.9. So I would take anywhere from about a negative 0.6 to a negative 1.2. All right, so you want to be somewhere in that range. So 0.6 to a 1.2, and then it has a negative sign just because it's pointing downward. And then anything in front of the mirror is real. Anything behind the mirror is virtual. This is a real image because it shows up in front of the mirror. I can put I can project an image right there, and you would actually be able to see it. Okay, the other type of mirror. So review of what we did yesterday. Today we're going to look at convex mirrors. These are going to be the type that it bulges outwards. So the mirror surface is like it's getting pushed out towards you. Okay, if you can't see things very well on my video, you have many convex mirrors at home. A spoon. The back side of a spoon is a convex mirror as well. It bulges towards you. All right, so how do things look far away? How do things look in the middle? And how do things look right up close to you. Okay, I'm gonna walk this towards you, and what you should see is it never flips upside down. Everything is always upright, and it always is kind of smaller than the starting object. All right, so as I walk this towards you, hopefully it works. You should never see anything upside down. It should always kind of be smaller and upright. For these types of mirrors, the difference between them is where you're going to put the focal point. So because the curve is in the opposite direction, when a light ray hits it, because of the shape of it, it's going to bounce off in line with a point behind the mirror instead of in front of a mirror. Okay, which means we're going to have to extend all of our lines behind the mirror today. Which means all of our images are going to be virtual. I hope if you ever get stranded on a deserted island and you're trying to flag down an airplane overhead, you want a concave mirror because that projected light, convex, does not do that. It just spreads light rays out. It doesn't put it into one nice little place. It doesn't blind you or flash you. So it makes only virtual images. All right, so go back to your colored system. Light ray for me, number one, is always red. So once again, use your straight edge. Lay it out. You're going to draw a straight line from the starting object until you hit the surface of the mirror. Once it hits the surface of the mirror, because of the curve, it's going to bounce off, but it's going to bounce off at an angle that goes through the focal point on the back side of the mirror. The actual light ray doesn't go through the mirror, it bounces off. We are just going to extend that line behind the mirror. Then I'm going to switch to blue, light ray number 2. Okay, this time for light ray number 2, you're going to line it up. It goes through the focal point, so you line it up so that your straight edge is from here to here. You want to line it up that if it could get through the mirror, it would go through the focal point. Right, so I line up my straight edge. If it were to continue, it would go straight through the focal point, but it can't get through the mirror. When it hits the mirror, it bounces back straight, parallel to this principal axis, and that is the line that we extend backwards. All right, so line it up with the focal point, draw your line, but when it hits the mirror, the line can't go through there, it bounces back straight. The straight piece is what we extend. Notice, these are never going to intersect. We learned yesterday when they don't intersect in front of the mirror, we have to extend our lines behind. We have an intersection point right here. That is what we see in the mirror. This arrow is smaller than the starting one. What we see in the mirror looks smaller than it started with. It is upright. It's above the dash line, so it's pointing upward. And this is what's going to be termed virtual because anything behind the mirror is virtual. Anything in front of the mirror would have been real. Convex can only make a virtual image because of the way it's shaped. All right, we're going to do one other one. I'm going to take it and I'm going to move it even closer. We saw with an actual mirror that it should still be smaller and upright. It's just going to push it closer. So going back to my red line, straight line until I hit the surface of the mirror. It then bounces off through the focal point, which is behind the mirror for convex. The actual light ray goes that way. We just line it up and extend the line behind the mirror. Second light ray, it lines up with the focal point. So you're drawing a line that would go through the focal point if it could get through the mirror. Use your straight edge to line it up, but it can't get through the mirror. When it hits the mirror, it bounces off. It bounces back straight or parallel to the dash line, and I extend that straight line backward. Once again, they don't meet in the front. We had to extend the lines in the back. When they meet, it is right back here as I switch to a different color. They meet right there, smaller, upright, and once again, virtual is anything behind the mirror. I can't put anything behind the mirror and project it because there's not actually light rays there. We just have to draw it like there are. All right, so convex, once again, you're gonna move to the next page, which is page 5. You are gonna have 2 convex ones to draw out, and then you're gonna have the second one, you're gonna do it once as a convex and once as a concave mirror. Notice convex is bulging toward the starting object, whereas concave was caving inward towards the starting object. Think of this like a circle. If you were to make this a whole circle, focal point would be in front for concave, and it would be behind for convex. All right, same thing as before. You're gonna start by looking at the height of your arrow. HO is gonna be 1.5. It is going to be 4.5 centimeters in front, so that's how far you measure it to be. And then you need a focal length from there. All right, so once again, to help set you up, you need to measure out 4.5 centimeters in front of the mirror. Dash it, and then the starting arrow needs to be 1.5 centimeters tall. Okay, that's my starting object that's looking in. My HO was 1.5 and my P was 4.5. I also need a focal length. It is convex, which means, think of this like a circle. Convex always goes behind, so I need to measure behind my mirror 3 centimeters, and then I notch it as an F. From here, I go to my 2 lines. You draw a straight line till you hit the surface of the mirror. It then bounces off through the focal point. Oops. The second light ray lines up with the focal point, but it has to stop when it gets to the mirror. And when it hits the mirror, it bounces back straight. I extend the straight line behind until I get an intersection point, which shows me what it is that I see in the mirror. I measure 2 things. I measure Q, the distance back to the mirror. So where it intersected, back to the mirror is Q, and then HI is the actual height of the intersection point, the height of the image that we see in the mirror. You will measure those. They should be within about a centimeter either way, so between about 1.3 and 2.3. This time your Q is going to be negative. When we do math tomorrow, it'll come out negative. But because we're behind the mirror, anything behind the mirror is negative. The height will be positive because it's pointing upright, and this is going to be a virtual image. All right, so you're going to finish off those 3 for class tomorrow. Thank you.